as I do this code. So you have an error here. Let's see how we can correct that error. So we have class students protected in English. In English, then class student 1, students is a class of students. Child stud is a class of students with a public member. Okay, we have a public member there. Then we have a function without a return type for set and get. Let me see if swapping this will give us a more agreeable way of doing it. I'm just going to see. So we have a problem where Papa in English. So let's see. Void set English int E. Int get English void. Int child students get English void. Return English. English is equals to E. So class child stud int child stud is going to be void because it doesn't have a member. It doesn't still have a value. Let's see if this will work. Nice. Okay, let me share the screen. So can you see that English for student 1 is equals to 78? Okay, English for student 1 is equals to 78. Let us go through the code again and see what happens. So we just had for English so that you could now go on your own and do for the rest. So we have a function, we have a protected member inside a parent class called student, a protected member called English, Eng. Then we have a member, we have a function, we have a child class called child stud. Inside it, these members should be public, okay? These members should be public. Why? So that they can be accessed within the main program. So that they can be accessed within the main program. So we have class students. Okay, we have class child stud, which is a class of students, and it has public members. Void set English. Now set is basically a keyword to allow the programmer to initialize a value. Okay, void set English, and that particular variable called English, it's going to be identified in another function it's going to be identified in another function, another member function called, it's going to be identified in another member function as E. Okay, so English is going to be identified in a member function as E. Okay, so English is goes to E, as you can see here. Okay, so void set English and int get English. Okay, void because we are not having a value yet until the programmer defines a value, and void also here because there's nothing to get until the programmer sets. Can you see that? So we have these members, and these are member functions, and then we are going to come here outside here, and then we're going to have a child class called child students. Child students is going to, this is normally what it's called a virtual function. Virtual functions are normally used when we are using child classes. Okay, and virtual functions are normally used outside the class. Okay, so int child student get English. In fact, we can even start with here so that we don't have to so that our code cannot look confused. All right, so we now begin with set English. Okay, so can you see this set English here? So we just come and say void child student set English int E. Okay, and then we have English is equals to E. All right, then int child student. So void child student is basically a virtual function for setting English as E. You see, setting English as E. Okay, and then here we have int child student, then get English void because there's nothing to get yet until the programmer sets a value. Okay, then return English when this function is called, it's going to return this value English. So when you go to main method, can you see what has happened? In the main method, we've just now we've just declared an object for child student because it is the one which has public members. Okay, you don't use, let me say this, you don't use a protected member to define an object if you want to access the members of that class. You don't use a protected class, you use a public class in the main function. So that's why we have not defined this object using the main parent class, because the parent class has been defined using protected. We have used the child instead because the child has public members. Okay, so child student one, and student one dot set English. After we've just done this, all these functions are going to be called. Which ones? These functions. So this function void set English, int E, and void set English. There. Those two functions are going to be called. Then when we have English for student one is equal, when we call this function get English, it's going to compute that and compute the other way, this one, so that it can return English. Okay, and already we have set the English. Okay, so when you run this, of course, it's going to give you that. It's going to give you this. Okay, English for student one is 78, and therefore you can do that for any other. You can do that for any other subjects. You can do that for any other subjects. Okay, you can do that for any other subjects. All right. So that brings us now to the end of the access modifiers, private and protected. Now I want to go, in the interest of time, I want to go now straight to the concept of polymorphism. And I want to teach you a very small thing about polymorphism. Now, polymorphism, I'm going to delete that. Okay, let me not delete it. Let me just keep it. Let me just create a new project. Console application. Next, C++. We're going to call it polymorphism. Polymorph. So so polymorphism is basically the ability of is the ability to take up many forms. It's derived from two Greek words, poly and morph. Poly means many, and morph means forms, like metamorphosis. Yeah, having many forms. So polymorphism is basically the ability to take up many forms. Are you together? Ability to take up many forms. Now, for instance, polymorphism really relates so much with inheritance, because inheritance is where objects or child classes can take up the properties of parents. Are we together? Now, I want us to combine inheritance where we had child classes. I want us to combine the concept of inheritance with polymorphism. Now, for instance, if you're a child and you have inherited the properties of your parents, but having inherited the properties of your parents, there are things that are unique to you that your parents don't possess, right? So there are characteristics or attributes about you that are not in your parents, but you have inherited their properties. So through inheritance, you have gotten their properties, but through polymorphism, you have your own unique features. Are we together? So polymorphism is basically, after inheriting the properties of a class, a child class is able to have its own unique features of those properties. Okay, it's able to have unique features of those properties. Now, let us have an example. Okay, let us have an example of a program. Now, this program is going to read as follows. The program is going to read as follows. Where the programmer defines, I hope I'm recording this. All right. Where the programmer defines the length the dimension of the dimensions of a square and the dimensions of a square and the radius of a circle. It then uses two child classes that each have the computation for area of square and computation for area of circle. Okay, can you see that? So we are told that the program should allow the user to define, and not the user, but the programmer, to define the dimensions of a square. The dimensions of a square is basically length. Okay, square doesn't have length and it just has length. And then the radius of a circle. But what we are going to do, we are going to use a length or L, whichever variable we are going to use, we're going to share that for radius and for length of a square. We're going to share that. And then it uses two child classes, and each child class has the computation for area. So one child class will have a function for area of square, and another child class will have a function for area of circle. Okay, and of course, probably it then displays the areas. Okay. Now, let's come to the program itself. So hash include stream, we have that. So before the main method, we have to declare a class, right? So a class called, we are going to have a class called shapes. Are we together? So this class shapes is going to have public members. These public members are going to be, let's use double this time. So double L, or let's say double length. Okay? And of course, double pi. Why are we using pi? Because we have a radius for circle. How are we going to compute the area of a circle? We need pi. Right? So double pi 3.142. That way. Okay. Then we are going now to have a child class. Okay. So class, we are going to call it class area. Class area. Okay. Class area. Class area is a class of shapes, and this is going to have a function for area. So of course, it's going to be public member. The members should be public so they can be accessed from within the main program. So class area shapes the member as a public, and this is going to have return length times length. So this is basically that, and then we are going to have class area. So we're going to say area square, and then area of circle. Okay. It's a class of shapes. Its members are going to be public, and then we are going to have what? We are going to have return pi, okay, pi times length times length. And when you come to the main function, we are going to have now the object. So we're going to have one object for, an object for square and an object for circle. So we are going to use which classes to define those objects? The child, where the functions are. Okay. So we are going to say area S, because that's a what? It's a child class. Okay. So area, was it area S? Yeah. Area S square. And then area C. Area C will be circle. And then we are now going to come here and say square dot length is equals to 5.6. Then circle dot width, not circle dot length. This length is going to be treated as a radius. It's going to be 7. Then we're going to see out area of square equals to it's going to be square dot there's a function we didn't have. We should have it like a function. So int, sorry, it's not int but double area. Sorry, this should have been that way. And then of course also here. Pi r squared, right? Pi times length times length. Okay. So let's see. Area S. Sorry. Square that way. Square dot area. Square dot, not square but just circle. Let me run this. Square dot length. Okay, so it has given me an error here. So now let's debug. Because we have 5 minutes left here. So let's debug this. Just wait. We have a function here. Let me simplify this program. Double area. Length times length. Return y times length times length. So shape square. Shape circle. Square dot length. Is it double? Okay. Square dot length is equals to 6.3. Then circle dot length 7. Area of square is equals to square dot area 2. Okay. Now this one doesn't have that. Okay. Okay, so can you see this? Okay, let me just share the screen. So it has given us the area of square is this, and the area of, oh, we didn't edit this. We edit area of circle is this. Now, let's go back to the code. So we have less than 2 minutes. Basically, let's first edit this. It can be circle. Basically, what we are having is a function called area, but this function called area has been used in two different ways. Okay, in here it has been used as area length times length, but it has been used as area height times length. In other words, it is the same function area, but it has been used in two different ways. Okay, it has been used in two different ways. Okay, so basically this is basically the concept of polymorphism, where a particular member of a class has been used in two different ways, but it is the same as in it is the same kind of computation. It is area. Okay, you can see we have less than a minute here. It is area. So this is basically the concept of polymorphism, where where we use two different computations for the same thing, right? It has taken up the properties of inheritance, but then it has had modifications, all right? So where we have area and this is area 2. So this is basically area and this is basically area. They are both area, but they have different computations. So that's the concept of polymorphism, different forms, okay? Different forms, right? You can see our time is elapsing here. So you can see that, yeah.